So today is actually our tutorial 6 and part 2. In this tutorial, basically we will cover the outline, that is plotting .dat files in Cadence. Oh, sorry, not in Cadence, in LaTeX. In LaTeX. Okay. So the last class we are actually generating some .dat file from Cadence. So these .dat files we will plot in overleaf. So without wasting any of time, let us start. So this is my overleaf, and I am adding here all the dat files here, and I performing the analysis here. That is already I generated the plot, so I will just demonstrate it. So this is actually FT into GM over ID versus GM over ID. So we need to generate this plot. So if I compile it and try to see it, you can see that your y-axis is FT into GM over ID, and your x-axis is actually GM over ID. And these are your different lengths. So we can actually plot anything versus anything in LaTeX. If you have some value and it is possible to extract the .dat files from the system, then you can actually plot anything versus anything in LaTeX. So after that, I plot here FT versus GM over ID. So if you see here, this is your FT versus GM over ID. All right, so our y-axis will be our parameters, and our x-axis is actually GM over ID. So we need to manually creating this curve. Actually, Cadence basically does not provide me this curve directly, but we can plot this FT versus GM over ID in also Cadence. So now we see the GM over GDS versus GM over ID. So you can see this is the GM over GDS, that is the intrinsic gain versus GM over ID. So these are for different lengths. So I also use a legend. If I suppose try to identify the 300 nanometer length, which color is actually my 300 nanometer? So I can remove the legend, and after that we compile it. So this color is actually 300 nanometer. So this line is actually 300 nanometer. Similarly, if you try to add more legend and recompile it, you can see this is for 500 nanometer. This is for 700 nanometer. So like that, you basically use a legend. Now try to show the GMORD versus overdrive voltage. Sometimes we need this plot for our design purpose. So this is a GMORD versus overdrive voltage plot. If we try to add legend here, so now recompile it. So we can see here our all the lengths with different type of colors mentioned here. Now we will see ID over W versus GM over ID plot. This is ID over W versus GM over ID plot. So ID over W is actually your current density. Now remaining plots are VD set versus GM over ID. So we compile it. Okay, so this is VD set versus GM over ID. So it actually implies that if you increase your GM over ID, in the x-axis, your VD set will be at the lower length. Because suppose you have just a typical value here. So it will touch this point and its corresponding value is like this. If your GM over ID is suppose here and in this point, and that time it may be something else. So basically you actually extract this data from your design. Anyway, so VGS of N versus GM over ID. That means your gate to source voltage versus GM over ID. All right, so you can see that this is the plot. If you increase your GM over ID, the gate voltage will be uh, reduced. If you increase your GM over ID, the gate voltage will be reduced. And finally, the remaining plot is overdrive voltage versus GM over ID. So if I compile it, you can see that this is the VOV versus GM over ID plot. So that's how we can actually plot our .dat files in LaTeX. Anything versus anything. You need to be just generate a proper graph and its corresponding data you need to extract from that software. And after that, you will modify the code a little bit by depending on your axis. And then you can use MATLAB or Excel or LaTeX, whatever it may be. So these are the important parameter versus GMO variety that I am actually show. And combinedly, I actually generate those PDF files. Basically, I'm generating a PDF file and rename this PDF file as a MOS characterization, because our objective is we want to characterize the MOSFETs. So for this reason, we need some plots. So we're generating those plots. It means that this is the characterization is actually done. We can characterize our MOSFET by using these curves, depending on our specs or something else. So if you see here in presentation mode, finally, these are the plot. So this is FT versus GM over ID plot. This is GM over GDS versus GM over ID plot. This is GM over ID versus overtype voltage. This is ID by W versus GM over ID. This is VD set versus GM over ID. And this is gate to source voltage of the NMOS versus GM over ID. And finally, this is the overtype voltage versus GM over ID. But this is a little bit introduction of the plotting of the LaTeX. So anyway, so this is the wrap up time of today's class. We try to characterize our NMOS, and that's why we are generating some plots. By depending on these plots, we can easily characterize our MOSFETs. And this is for the NMOS. These all curves for the NMOS. But we need these all curves also for PMOS. So the next video will explain, or I will explain, how to plot the PMOS important parameters. That means how to characterize the PMOS in cadence. And with these, I conclude this segment. Thanks for watching.